Let's take a look at velocity and acceleration. And this definition we have here is in 2 dimensions, but it still applies to 3 dimensions. You just add on your third component function. This says if x and y are as twice differentiable functions of t, and r is a vector-valued function, given by r of t is equal to x of ti plus y of tj, aka the position vector, then your velocity, v of t, is equal to r prime, your acceleration, a of t, is equal to r double prime, and your speed is equal to the magnitude of v, or the magnitude of r prime. Let's take a look at our first problem here. We got r is equal to t squared I plus 5t j. They give us 0.15. Okay, so position vector r describes the path of an object moving in the xy plane. Sketch the graph of the path, and then sketch the velocity and acceleration vectors at the given point. Well, let's first look at the graph. If I take a look at the x component, that's t squared, so x is equal to t squared, and the y component is 5t. Well, I'll start with the smaller power of t, the y equals 5t, and divide both sides by 5. So we got y over 5 is equal to t. Now we're going to plug this into the other one. So plug that into x is equal to t squared. So we got x is equal to y over 5 squared. X is equal to y squared over 25. Now if I were to sketch this, we have a point at 0, 0. At y is equal to 5. X is going to equal to 1. And at y is equal to negative 5. You'll have x is equal to 1. So our graph is going to look like this down here. Okay. Now, it wants us to find the velocity and acceleration vectors. Well, our velocity vector v is equal to our first derivative of r, which would be 2ti plus 5j. So we're just taking the derivative of each component function. Now our acceleration, a of t, is going to equal the second derivative. So we'll just take derivative of what we just found. So derivative of 2t is 2. So we've got 2i, and 5 is a number, so it drops away. Now specifically, they're asking for it at this point. So now this point is given in terms of x and y. But the variable that's in our v and a is t's. So we need to find out what t is. Well, we know what x is. X is t squared. So set t squared equal to 1. So we're going to find t here. So if I say t squared is equal to 1, and y is 5, and y equals 5t. So we'll set 5t is equal to 5. Now this is square root property. We'll drop our squared. Oops. Drop our squared, put a plus or minus square root around the other side. And this one, we'll divide both sides by 5. And we get t is equal to 1. Square root of 1 is 1. Now where they're both true, and that's what you're looking for, is at t is equal to 1. So what we're going to do is we're going to take that now and plug that into our velocity and acceleration. So v of 1 is equal to, and I'm just going to plug 1 in for the t. So we got 2 times 1i plus 5j. So that gives us 2i plus 5j. Now a of 1. A was 2i. There's no t to plug into, so that's just 2i. Now I'm going to try to graph these on here. They won't look great. so don't get too excited. Okay, so from this point right here, 1, 5, because that's the point they give us. They give us 1, 5. We want to go, this is our x components, we want to go right 2 and up 5. So right 2, 1, 2, 3, 4, 5, and up 5. Okay, so right 2 and up 5. Would look like that. Now the other one. This says right 2. So if I go right 2, it'll look like that. Let me show you a good picture now. We'll go to WinPlot. Okay, I'm going to do window, 2 dimensions, and I know you can't see this, so I'll just kind of describe what I'm doing. Choose equation, and choose parametric. F of t is going to equal to t squared, so I do t caret 2. G of t is 5t, so I'll put in 5t. Low t, I'm going to put in -6, and high t, I'll put in a +6. And then I'll click OK. Okay, now I need to zoom out here, so I'm going to do my click over inside the image, and I'll do my page down. Okay, now we're looking at the point 1, 5. So let me go ahead and just put a point there. So I'll do equation, point, and then choose XY. Then I'll do 1 and 5. And click dot size, I'll put 4 in, and then I'll click OK. Let me do an edit on that. I want to make that a solid, not open. There we go. So there's our point. Now let me do a click inside the image, do a page down a little bit more, so I got a little bit more space to see. And I'm going to choose equation, and I'll choose segment, and I'll choose XY. Now this is asking us from where, and I'm going to put in x1 is 1 and y1 is 5. Now remember what we said about our velocity. We said it's 2I plus 5j, so we're going to go right 2 and up 5. Well, I'm going to add 2 to the existing x value. The existing x value is 1, so 1 plus 2 gives us 3. And for the y, we said we're going to go, what did I say, up 5? Yeah, up 5. The existing y value, y1 was 5, so we got 5 plus 5, or 10. Now I'm going to put an arrow at the end of that, so I'll click P2 here, and arrow size will make 14. And click OK. And there's our velocity vector. Now our acceleration vector from that point. We'll choose equation and choose segment and then choose XY. Now the x1 was 1, the y1 is 5. That's our starting place. And we said we're going to go right 2, if I remember right. Yeah, right 2, which means our x value increased by 2. So it was 1, x1 is equal to 1, so 1 plus 2 gives us 3. And the y value will stay as is, which was 5. Now click on P2 for my arrow, choose my arrow size 14, click OK, and it looks like that. So that's what it should look like versus my rough sketch. Let's look at our next problem. Okay, so we got R of t is equal to t squared I plus t to the 4th j. Okay, sketch of it. Well, we got x is equal to t squared and y is equal to t to the 4th. Now y is equal to t to the 4th. I could rewrite that as t squared times t squared. And over here we said t squared is equal to x. So this is y is equal to x times x, or y is equal to x squared. Now this is a real interesting one, because we know what y is equal to x squared looks like. That's our parabola. But if we plug this into our graphing utility, WinPlot, let's go see what it looks like. And then we'll talk about why we're seeing what we're seeing. So I do window, 2 dimensions, I choose equation, parametric, and f of t is t squared, so I do t caret 2. G of t is t to the 4th, so I do t caret 4. Caret is above your 6 on your keyboard. Let's see. My low t, I'll put in -2, and then I'll put in +2 for the high t. And then I'll click OK. I'm going to click in here and do some zooming out. There's a problem with this. Y is equal to x squared is a parabola. It's on both sides. That our wind plot only gave us the right side. Let's think y. Think what this about this vector valued function over here. T squared, that's always positive. T to the fourth, that's always positive. Now this is your x component and this is your y component, so that's saying your x and y are both going to be positive, always. Well, this is where x and y are both positive, so that's why they don't include the left side. So you have to be careful about it. Once you do it by hand here and you get the y is equal to x squared, your first inclination is that your graph's going to look like this right here. But we know from what we just looked at that it isn't over here. It's just this side. Sometimes the graphing utility will help point out things that you overlook by hand, and sometimes when you're doing things by hand, it'll point out things that your graphing utility didn't give you because either it's incorrect or maybe you didn't put appropriate t-values in there to get a true picture. Okay, well let's find our velocity vector. Velocity is a derivative of r, so we'll take r prime, which will give us 2ti plus 4t to the third j. And our acceleration, take derivative again, so this will be a second derivative of r, which will be 2i plus 12t squared j. Okay, but what they're asking for in this problem is they're asking at the point 416. So we need to find out what t value is at that point. Well, we said x is equal to t squared, so we said t squared is equal to 4. And we said y is equal to t to the fourth, so we said t to the fourth equals 16. Now drop the squared, so we got t is equal to plus or minus square root of 4. T is equal to plus or minus 2. Now over here we're going to do the same type of thing. This is like t to the 4 over 1 power equals 16. And then if I raise both sides to the reciprocal of this, the reciprocal of that would be 1 over 4. That's power principle. This would be 16 to the 1 over 4. Now whenever you got in fraction form, rational exponents, your number on top is even. Then that means you always have to put a plus or minus on the other side. So this is going to become t is equal to plus or minus, and the fourth root, or the 16 to the 1/4 is the fourth root of 16, which is equal to plus or minus 2. Okay, now they're both plus or minus 2. But remember what I said. If we look at just this over here, positive t and negative t both give us the same x and y in this problem. So let's take a look at t is equal to 2. And let's find our velocity. So v of 2 is going to equal to 2 times 2i plus 4 times 2 to the third j. So I'm just plugging in my my 2 for the t here. So that gives us 4i plus 2 to the third is 8 times 4 is 32, so 32j. So that's our velocity and our acceleration. Well, we got 2i, so there's no t to plug into there, plus 12 times t squared, so we got 2 squared j, which gives us 2i. 2 squared is 4 times 12 is 48 j. Okay, now if I were to graph those, and they'll occur at the point 416, which hopefully I can actually see on here. Okay, that's not going to be very good, is it? Let me edit this and change that to high T of 4. There we go. Okay, 416. Let me go ahead and put a point there. And I'm going to do an equation. I wonder if I make this bigger, if you can see it a little bit better. A little bit maybe, not much. Okay, I'll do an equation, and I'll choose point, and I'll choose XY. And I'll choose 416. Dot size I'll make 4, just so it's a little bit bigger, and I'll make it solid. And I'll click OK. Okay, that's what we're working at. Now I'm going to do an equation, and choose segment, and then choose XY. It's going to come from 416, so do x1 is 4, y1 is 16. And then it's 432 for my velocity. So I'm going to add 4 to x1, which was 4. So 4 plus 4 is 8. And I'll add 16 plus 32, which gives us 48. Now I'll put an arrow on there, and I'll make it 14. And click OK. Okay. I have to go out a little bit so you can actually see that. Oh, that's what it looks like. Okay, let's do our other one. So I'm going to do an equation. And I'll choose my segment and XY. And it's going to come from 416 again. So x1 is 4, y1 is 16. And we got 2 and 48. So 4 plus 2 gives us 6. And for 48, was it 48? Yeah, 48 plus 16, 58, 64. Put an arrow on that, and then click OK. Assuming I added everything correctly and everything, that would give us our graph. So again, from that point, you use these to use that to get your other portions. Let me save this. There we go. So we calc 3, acceleration and velocity. Or I should say velocity and acceleration. Page 01.pdf. There we go. And let's take a look at our next problem. Grab a drink here. Okay. Same instructions. So we've got R is equal to 3 cosine ti plus 3 sine tj, and set point 3, 0. Same instructions. Well, if I were to graph this, this would be x is equal to 3 cosine t, y is equal to 3 sine t. Divide both sides by 3. You got x over 3 is equal to cosine t, and y over 3 is equal to sine t. Square both sides, and we have x squared over 9 is equal to cosine squared, and y squared over 9 is equal to sine squared. Now add the left sides together, and I have x squared over 9 plus y squared over 9, and add together the right sides, and I got cosine squared plus sine squared. So I got x squared over 9 plus y squared over 9, and cosine squared plus sine squared is 1. Now multiply everything by 9, and I get x squared plus y squared is equal to 9. So this is a circle of radius 3. There we go. Our graph would look like that. Now we need to find our velocity vector, which is the first derivative of r. Well, the derivative of cosine is negative sine, so this becomes negative 3 sine t I. And derivative of sine is cosine, so this becomes 3 cosine t j. Now our acceleration vector. The derivative of sine is cosine, so this is negative 3 cosine ti, and derivative of cosine is negative sine, so this is minus 3 sine t j. Now we need to find out what our t value is. So this is our x. So and x we said was 3 cosine t, so we'll say 3 cosine t is equal to 3. And sine, or the y equals 3 sine t, so y is equal to that, and y is 0. So we've got 3 sine t is equal to 0. Now divide both sides by 3 here, and we've got cosine is equal to 1. Divide both sides by 3 here, and we've got sine is equal to 0. And if I go around the unit circle, you do this one a little bit differently. It's not where these agree, but if you look at this on a unit circle where cosine is 1 and sine is 0, that occurs at t is equal to 0. So we now want to plug 0 in for our t. So v of 0 is going to equal to negative 3 sine of 0 I plus 3 cosine of 0 j. Well, sine of 0 is 0. Cosine of 0 is 1, so 3 times 1 is 3, times j gives us 3j. For acceleration, a of 0, we're going to have negative 3 cosine 0 I minus 3 sine of 0 j. Again, the sine of 0 drops away, and cosine of 0 is 1, so this gives us negative 3i. If we look at the graph of those, this 3j, there is no I, so x doesn't change, but y increases by 3. Which means from this point, which is where we're looking, 3, 0, we're going to go up 3 for acceleration, and for our velocity, sorry. For acceleration, it's negative 3, so from this point I go back 3, like that. And that's our velocity and acceleration vectors. Okay, let's look at our next problem. Scroll down here. I got r is going to equal to 4ti plus 2tj plus tk. And instructions are find velocity, speed, and acceleration. Velocity we've already seen. Just take derivative of it. So derivative of r, which is going to give us 4i plus 2j plus t becomes 1, so that's 1k or just k. Now our acceleration is the second derivative of r. Well, we take derivative again, and 4, 2, and 1 all become 0. Now this is not actually 0. This is the 0 vector, which if I were to put it in the vector form would look like this, 0, 0, 0. So realize it's not actually 0. Now our speed. That was our bottom formula here, where you take the magnitude of r prime. Well, r prime is right here, so we got square root of, and you take each one of the component functions off and you square it. So we got 4 squared plus 2 squared plus 1 squared, which gives us 16 plus 4 plus 1, which gives us square root of 21. So here's our velocity vector. Here's our acceleration vector value function, I should say. And then here's our speed. Let me save this and look at the next problem. So r is equal to t to the third I plus t squared j plus 5tk. And our velocity, first derivative of r, so this will be 3t squared I plus 2tj plus 5k. And our acceleration is the second derivative, so we just take derivative of what we just found. So that gives us 6ti plus 2j, and then the 5k drops away, because that's just a number. Our speed. Is the magnitude of our first derivative, which is v. So I'll have the square root, and I'll square each component function. So I got 3t squared squared plus 2t squared plus 5 squared. So that gives us 9t to the fourth plus 4t squared plus 25. Now realize that the speed varies because we have a variable left in there, the t component, or t. So that's going to be variable speed throughout this. Number 6. Got r is equal to different notation, cosine t, sine t, and 5t. Realize this is the same as this up here. I could put cosine ti plus sine tj plus 5tk. So you may find it easier to use this form or that form. It's up to you. So our velocity. Take first derivative of r. Well, derivative of cosine is negative sine. The derivative of sine is cosine. And the derivative of 5t is 5. And for acceleration, take derivative of that again. Well, we've got minus sine, so the negative carries down. Derivative of sine is cosine. And derivative of cosine is negative sine, so it becomes a negative sine t. And then 5 goes to 0. Now for our speed, be the magnitude of v, which gives us square root of negative sine t squared plus cosine t squared plus 5 squared. Which gives us, when you square a negative, becomes positive. So we got sine squared plus cosine squared plus 25. Sine squared plus cosine squared is 1. So we got 1 plus 25, or square root of 26. So these would be our answers. Let's look at the next one. I might have room here. Yeah, I think I do. Okay, so here they're giving us the acceleration vector. 3i plus 2j minus 5k. And it says use a given acceleration function to find a velocity and position vectors. And v of 0 is equal to the 0 vector. And r of 0 is equal to the 0 vector. Now notice the 0 inside the parentheses here is a t. But this is actually the 0 vector. Okay, they want us to go backwards here. They want us to first find v. To find v, we're going to take the integral of 3i plus 2j minus 5k with respect to t. Well, that gives us 3ti plus 2tj minus 5tk plus our constant vector. Now, this right here means t is equal to 0. So plug in t is equal to 0. Because we need to find out what the constant vector is. Well, if I plug in, let's see, this would be v of 0 is equal to 3 times 0I plus 2 times 0j minus 5 times 0k plus our constant vector. Well, these zeros all drop away, and v of 0 up here, it says is a 0 vector. So this is the 0 vector, and all those drop away. So that tells us our constant vector is equal to the 0 vector, which means this right here now becomes v is equal to 3ti plus 2tj minus 5tk. So now we need to find our acceleration vector. Or, the position vector. So r. To go backwards, we're going to take the integral of v. So we've got 3ti plus 2tj minus 5tk with respect to t. So r, add 1 to our power, divide by new power, so that gives us 3/2 t squared I plus t squared j minus 5/2 t squared k plus our constant vector. Well, this is here is t. So now we want to plug in t is equal to 0. Whatever number was inside these parentheses right here is what we plug in. Okay, so then we're going to get r of 0 is equal to 3/2 times 0 squared I plus 0 squared j minus 5/2 0 squared k plus our constant vector. Well, r of 0 up here we said was 0 vector. So that's, we can place a 0 vector. 0 squared is 0 times 3/2 is 0. That all drops away. All these zeros drop away, and we're left with the constant vector. So that says the constant vector is a 0 vector. So this this one right here now gives us r is equal to 3/2 t squared I plus t squared j minus 5/2 t squared k. And that's our position vector. What are they asking for? Find the velocity right here, the position vector, and then they say find a position at time t equals 2. So at t is equal to 2, we're going to plug that into our position vector, and we got r of 2 is equal to 3/2 times 2 squared I plus 2 squared j minus 5/2 2 squared k. Well, this is 4 times 3 is 12, divided by 2 is 6. We got 6i. 2 squared is 4, so we got 4j. Here we got 2 squared is 4, divided by 2 is 2, times that 10 minus 10k. So we didn't make a basic math error somewhere. So those would be our answers. Let me save that. That one is kind of boring because our initial conditions given were both at 0 vectors. The next two will be a little bit more exciting. There we go. Let's look at number 8. Okay, so it gives us our acceleration vector is equal to 2tj minus 3tk, and it gives us initial conditions. Our velocity vector at 0 is equal to 2j, and our position vector at 0 is equal to 4k. There we go. Okay, so let's go backwards to find our velocity vector. We're going to take the integral of our acceleration vector, which is the integral of 2tj minus 3tk with respect to t. So our velocity vector is going to equal to t squared or j. That is a j, isn't it? J and k? Yeah, j and k. There is no I. So j minus 3/2 t squared k plus our constant vector. Okay. Let's shift my position here. There we go. Now, notice here, the t value is 0. So that means we're going to plug in t is equal to 0. You plug in whatever value you see here. It's probably always going to be 0 for these problems, but it doesn't have to be. T is equal to 0 is a good item to be able to measure, because that's like at your very starting, which you can easily measure. So we'll put 0 in for t, so we've got 0 squared j minus 3/2 0 squared k plus our constant vector. 0 squared j drops away, minus 3/2 0 squared k drops away, so we've got v of 0 is equal to our constant vector. But v of 0 is equal to 2j. So we're going to replace v of 0 with 2j. So then, we now find our constant vector. So our velocity now becomes, we can plug that in for c. So we've got v of t is equal to t squared j minus 3/2 t squared k plus 2j. That's our constant vector. Now I'm going to merge it with my other j portion. So my velocity vector is going to equal to t squared plus 2j minus 3/2 t squared k. Okay, well, we need to go back one more. So we want to find our position vector. The position vector is equal to the integral of the velocity vector. So we'll have the integral of t squared plus 2j minus 3/2 t squared k with respect to t. So that gives us our position vector is going to equal to, add 1 to your power divided by new power. So that's 1/3 t to the third plus 2t j. And then minus 1/2 t to the third k plus our constant vector. Now when I added 1 to the power to that, it became the third power, and I divided by 3, that canceled with this 3. Okay. And I'm assuming it's 0 again, but let me go up here and look. Again, notice the value in right here, that's your t value. So yet again, t is equal to 0. So that's what we're going to do. We're going to plug in t is equal to 0. So we're going to have r of 0 is equal to 1/3 times 0 to the third plus 2 times 0 j minus, so minus 1/2 0 to the third k plus our constant vector. Well, all these zeros drop away, so we got r of 0 is equal to our constant vector. Well, let's go up here. r of 0 is equal to 4k. So now we're going to replace the r of 0 with 4k. So this is, why am I having so much trouble writing? 4k is equal to our constant vector. So now this position vector right here now becomes, let me circle, they were asking for the velocity vector, so there's our first answer. So I now plug 4k in for the c. So we're going to have r is equal to 1/3 t to the third plus 2t j minus 1/2 t to the third k plus 4k. Again, we replace the c with 4k. Well, I want to merge together my k portions, so I'm going to have r is equal to 1/3 t to the third plus 2t j plus negative 1/2 t to the third plus 4k. And that's our position vector. Now they want to know the position at time t equals 2. So at t is equal to 2, we're going to find r of 2 is equal to 1/3 times 2 to the third power plus 2 times 2j plus negative 1/2 times 2 to the third plus 4k. 2 to the third is 8, so this becomes 8/3 plus 4j. And this is 8, so it gives us 8 times negative 1/2 is negative 4. So we've got negative 4 plus 4k. That's weird. 2, 4, 8. Divided by 2 is 4, negative 4. That's right. So that drops away. So we got 4 times 3 is 12, plus 8 is 20. So we have 20/3 j. So we need to make a basic math error somewhere. Okay, so let me save that. There we go. And I'm going to check something here. Audio. Hello, hello. Yeah, it's still recording. I heard a little weird sound on the thing. I was wondering if my computer quit working. Okay. Sometimes the volume will just go out. I'm plowing right ahead, just happy as can be, and it's not recording any of it. Hopefully that's not happening now. Okay, number 9. Now we're doing this with, in this particular problem, with just 2 components, the I and j, but again, you can have 3, like we saw in previous. So A, our acceleration vector, is equal to cosine t I minus 2 sine tj. And our initial conditions, our velocity vector at 0 is equal to 3i plus 2j. And our position vector at 0 is equal to 2i. Okay, well, going backwards, we need to find our velocity vector. So our velocity is equal to the integral of a, which will be the integral of cosine ti minus 2 sine tj. Well, the integral of cosine is sine, so this is sine ti, and the integral of sine is negative cosine. So negative negative would make this a positive 2 cosine tj plus our constant vector. Up here, t is equal to 0. So that's what we'll do. We'll plug in t is equal to 0. So we got v of 0 equals sine of 0 I plus 2 cosine of 0 j plus our constant vector. Well, v of 0 up here we said was 3i plus 2j. So I'll replace the left side with 3i plus 2j. Sine of 0 is 0, so that drops away. Cosine of 0 is 1, so that gives us 2j plus our constant vector. Now we won't get the constant vector by itself, so I'm going to take the 2j over to the left side. So we get 3i plus 2j minus 2j equals our constant vector, or our constant vector is just equal to 3i. So our velocity vector now becomes velocity is equal to sine t I plus 2 cosine t j plus 3i. We replace our constant vector, the c, with 3i. Now I want to merge that together with our other I portion. So we're going to have sine t plus 3i plus 2 cosine t j. Well, now we're ready to take it back one more step. We want to find our position vector. So r is equal to the integral of v, which will be the integral of sine t plus 3i plus 2 cosine t j dt. So r, position vector, the integral of sine is negative cosine, so that'll be a negative cosine t, and 3 just becomes 3t I, and the integral of cosine is sine, so this becomes plus 2 sine t j plus our constant vector. Well, we need to find out what our constant vector is, so let's go back up to our initial conditions. And it said r of 0, so this is t, so it's saying t is equal to 0 is equal to 2i. So plug in t is equal to 0 again. So we're going to have r of 0 is equal to negative cosine of 0 plus 3 times 0 I plus 2 sine of 0 j plus our constant vector. Now r of 0, from up above, r of 0 is equal to 2i. So we replace the r of 0 on the left side with 2i. Now sine 0 is 0, so that drops away. 3 times 0 is 0, so that drops away. Cosine of 0 is 1, so that's negative 1i, or negative I. So negative I plus our constant vector. Take negative I to the left side, it becomes 2i plus I equals our constant vector, or our constant vector is equal to 3i. Guess that was the first piece they were asking for. Okay, so then our position vector now becomes r is equal to negative cosine t plus 3t I plus 2 sine t j, and we replace the constant vector with 3i. Now I want to merge together the i's. So we're going to have negative cosine t plus 3t plus 3i plus 2 sine t j. And that's our position vector. Now, specifically, they're wanting to know at t is equal to 5 pi over 3. Trying to find position. So let's plug that in. So r of 5 pi over 3 is going to equal to negative cosine of 5 pi over 3 plus 3 times 5 pi over 3 plus 3i plus 2 sine of 5 pi over 3j. And let me think this through. Okay, 5 pi over 3. 3 pi, 4 pi, 5 pi. That's equal to 1/2. So that'll be negative 1/2. And those 3's cancel. So plus 5 pi plus 3i. And then plus 2. And sine 5 pi over 3 is negative square root of 3 over 2. J. So I'll merge together the 3 and the negative 1/2. So that gives me 5/2. 3 times 2 is 6, plus the negative 1 gives us 5. So that's 5/2 plus 5 pi I. Those 2's cancel. So minus square root of 3j. And I can merge these together. 5 pi times 2 is, this is a mixed number. 5 pi times 2 is 10 pi plus 5. So we got, actually, I'll just leave it in that form. Probably not a whole lot of benefit to putting that as a single fraction. So scratch that. That's our answer. So let me save that. Next problem is a little bit different. It's based upon this formula, position function for a projectile. Neglecting air resistance, the path of a projectile launched from, that should be from, an initial height h with initial speed v0 and angle of elevation theta is described by the vector function r of t is equal to v0 cosine theta t I plus h plus v0 sine theta t minus 1/2 g t squared j, where g is acceleration due to gravity. And the problems in this particular section, the ones we're going to look at anyway, are based upon 32 feet per second. So let's look at our first one here. It says, find a vector value function for the path of a projectile launched at a height of 20 feet. So they're telling us our initial height is 20. So h is 20. Above the ground with initial velocity of 100 feet per second. So v0 is 100. This is 100 feet. This is 100 feet per second. And an angle of 45 degrees above the horizontal. So theta is equal to 45 degrees. Okay, and it says to find the vector value function. We'll write down my formula. R of t is equal to v0 cosine theta t I plus h plus v0 sine theta t minus 1/2 g t squared j. So r of t is going to equal to v0 was 100 feet per second. Cosine of theta, so cosine of 45 degrees, t I plus h, which was 20 feet, plus v0, which is 100 feet per second, times sine theta, so sine 45 degrees, times t, minus 1/2 g, which was 32 feet per second, so 32 feet per second, times t squared, and then j. And okay, let's see here. Now, the cosine of 45 degrees is square root of 2 over 2. So this is 100 feet per second times square root of 2 over 2 t I plus 20 feet plus 100 feet per second. And that's square root of 2 over 2. T. The 1/2 here cancels that 32, so that gives us 16. So minus 16 feet per second, T squared, J. It's probably not a whole lot of benefit to simplifying that further. So that's our answer. Let me save that page. Let's take a look at another problem. Number 11. Okay, a baseball hit 5 feet above the ground. So here we are, initial height, 5 feet. So okay, they're telling us H is 5. So it's hit here. Here's our ball. And at an angle of 30 degrees. So it's coming up 30 degrees. So they're telling us theta is equal to 30 degrees. And it's caught by an outfielder 5 feet. So it's caught over here, 5 feet above the ground, 200 feet from the plate, which means the distance here, going out to here, is 200 feet. What is the initial speed of the ball? So what is V naught? We'll do that first. Okay. Now our formula. This is a position vector. So R of t is equal to V naught cosine theta t I plus H plus V naught sine theta t minus 1/2 g t squared j. Okay, now position vector. What that indicates is your x and y component. Well, this is our x, it's out 200. And our y is the height here, which is 5. Equals V naught we don't know. Cosine of 30 degrees t I plus our initial height, which is h, which is 5, plus V naught, which we don't know, sine of 30 degrees t minus 1/2 g. We're going to use 32 feet per second. I'm going to be sloppy on this one. I'm not going to put the units of measure. If you're a physics person, you just kind of, your stomach just rolled over, but that's okay. I can live with that. We're just interested in the calculus math part. Okay. So then, let's see, cosine of 30 degrees is equal to 1/2. Cosine is our x, and if we look on our unit circle at, wait a minute, 30 degrees. Boy, that would have been bad. I would have screwed that up. 30 degrees is down here, isn't it? 60 degrees is up there, which means the cosine is our x. That's square root of 3 over 2. So this becomes square root of 3 over 2 V naught t I. And this over here, we got 5 plus V naught we don't know. Sine of 30 degrees is 1/2. T minus, that gives us 16 t squared j. So I'm going to equate these. I'm going to set this one right here equal to this. So I got square root of 3 over 2 V naught t is equal to 200. And then I'm going to equate the y portion. So I'll equate the 5 with this right here. So we're going to have 5 is equal to 5 plus V naught times 1/2 t minus 16 t squared. Well, over here, if I solve, we're wanting v naught, so I want to solve this for t. So I'll multiply both sides by 2 to begin with. So I got square root of 3 v naught t is equal to 400. And then, like I said, I'm solving for t, so I'm going to divide both sides by square root of 3 v naught. So we got 400 over square root of 3 v naught. Now we can take this and plug it into our other one. But let's do a little bit of simplifying first. Both have 5s on each side, so this and this will cancel. And we get 0 is equal to 1/2 v naught t minus 16 t squared. Well, we just said t is equal to this value, so let's plug that in. So we got 1/2 v naught times 400 over square root of 3 v naught minus 16 times 400 over square root of 3 v naught squared. Okay, let me double check myself here. Okay, 400 square root of 3. Yeah, it looks right. Well, the 1/2 and the 400, that becomes 200. V naught's going to cancel, so that gives us 200 over square root of 3 minus 16. Let me double check that. Okay, yeah. Minus 16 times this, that gives us 1600. So that means that, 4 zeros. Square this, that becomes 3. Square that, that becomes v naught squared. Okay. Now, I'm going to take this negative over to the left side, so it becomes a positive 16. And then we've got 16, or, well, that made zeros. 3 v naught squared equals 200 over square root of 3. Let me get my calculator here. 16 times 160,000. Okay. So that gives us 256, 4 zeros, over 3 v naught squared equals 200 over square root of 3. Divide that by 3. Doesn't go into it evenly. Okay. I'm going to cross multiply. So I'll take 3 v naught squared times 200 equals square root of 3 times 256. Or that is 2,560,000. Okay. So then I'll divide, or this gives us 600 v naught squared. 6, 1, 2, 3, 4, square root of 3. And divide both sides by 600. And let me see, that divided by 600. Divided by 600. That doesn't go nicely. But some of the zeros would cancel anyway. So this would be 256, 1, 2, 3, 4 over 600. Square root of 3. And let's see, what's that become? Like that. So then we've got v naught squared is equal to 2560 by 6. Use my calculator to cheat a little bit here. 1280 over 3 square root of 3. And then v naught would equal to the square root of that. And of course, I don't know if this even makes any sense, because I kind of made the numbers up. But that would give us our initial velocity, assuming I didn't make a basic math error somewhere. If nothing else, you see the general thought process goes into it. Now I'm out of room here, so let me write down something. Okay. 1/2 t 16t squared v naught square root of 1280 square root of 3 over, excuse me, 3. Okay. Let me save that. And then the second part of the problem. It says find the how high does it rise? In order to find out how high it rises, you got to take the derivative of your y portion and then set it equal to 0. So we got our y portion was 5 plus v naught, which was square root of 1280 square root of 3 over 3 times 1/2 t minus 16t squared. So that's our y portion. Just out of curiosity, I wonder what that's equal to, that v. So square root of 1280 times the square root of 3 divided by 3. Velocity is 27.18. It's not very much for a ball hitting. Probably like how I'd hit. Okay, so let's take derivative. Well, t drops away, we're just left with this, and the 5 drops away, of course. So we're going to have 1/2 square root of 1280 square root of 3 over 3 minus 32t. Then we're going to set that equal to 0. And I'll take negative 32 over, so we've got 1/2 square root of 1280 square root of 3 over 3 equals 32t. Divide both sides by 32, and we're going to have 1/2 1280 square root of 3 over 3 divided by 32. And I could spend some time simplifying that, but that's good enough there. Let's see, just out of curiosity, what that's equal to. Got that times 1/2, 5, divided by 32. See if it even 0.42 seconds. Like I say, I made the numbers up, so didn't put any kind of effort into making them realistic. And that's the end of that problem, assuming no basic math errors, which probability's probably kind of high. I made a basic math error somewhere in this video, but we're done. Let's see. So I'm going to stop the recorders.